In the previous video we've done a big thing, which is interfacing a human player with the web UI. In this video I'll show how to do the same with a computer-controlled player. The big deal with this is that the code we had previously is somewhat specialized to the human player, and I want to show just how exactly to adapt the program so that the minimal changes are necessary to the codebase. It will be a very smooth extension. Conceptually, games are made out of chance, action and terminal nodes, and we can use that to generalize the players. Let us focus on the Leduc game for a bit. We've already factored out the important functionality relating to the sampling of the cards and the action selection from the game logic by using this interface. We could have started out by trying to make it more general, but in my experience I found that instead of anticipating what you should factor out, it is best to first write very specific code and then factor out the patterns afterwards. The game logic has been factored out completely and we won't need to go back and touch it again. That means we can focus on writing new code and factoring out this iLeduc game interface itself. Let me show you how I did that. I pared down the 6 nodes to the key ones, in essence abstracting the 6 that I had previously down to 3. You might be wondering whether there is a point to this. I mean, take a look at this chance node. All it does is sample one of the remaining cards in the deck and passes it into the continuation along with the mask. What else could we need? Well, some algorithms need to enumerate all the remaining cards rather than just pick one of them. This is going to be shown in the next video. Because we've written the game in continuation passing style, reusing the same logic for both the computer and the human player is very easy. If we hadn't done this, it would have been very hard. As you can see, the random player just samples one of the actions that are allowed, while the human player sends a message to the UI through the relay. The terminal is much the same as before. And now that we have all this functionality in separate interfaces, we can compose it together in different ways. Here, the chance and the terminal nodes just pass the arguments along to their respective interfaces, but in the action node, the program checks for the player ID and then routes accordingly. The Leduc game class is much the same as before. The main difference compared to before is that I factored out the actual player-related functionality from it. I've changed the game logic so that now the deck mask is passed through the continuation rather than being handled in the game itself. There isn't much more we need to do in order to enable the multiplayer functionality. Let's give the game a try. To beat the random player, you just want to keep raising. If you like this video, then click the like button and subscribe. I appreciate it. That's all for this video. In the next one, we'll go a step further and actually train the game theory optimal agents. We'll bring in the counterfactual regret algorithm. So look forward to that, and I'll see you in the next video.